So we welcome you all to the 2019 edition of COMSNETS panel discussion. Today's panel topic is man versus machine. Humans need not apply. So you can go all out for vacations in Hawaii or whatever. We have something in common for all the panelists today. So they all see red, right? So we have the red states. Not that I care, but just FYI. I think Falco Dressler is also from red Germany, whatever that means. This is going to be our panel bot from the 2028 panel, so beware. This is the timeline. So introduction by me, I am not getting beat, but everyone else will be beat. I am very responsible with regard to time, so I will stop at exactly 7 minutes if you're paying attention. So opening comments by panelists. Every panelist will elevate himself or herself with a 2-minute pitch, followed by presentation by each panelist for 6 minutes, and the rest is going to be Q&A till we are thrown out of this room. What is the definition of AI? I'm sure all of you know that, but I'm going to just recap. AI is a branch of computer science dealing with the simulation of intelligent behavior in computers, and it's the capability of a machine to imitate human intelligent behavior. There are two types of AI, applied AI and generalized AI. And generalized AI is basically what led to machine learning, which is technically a branch of AI, but it's more specific than the overall paradigm. Machine learning is based on the idea that we can build machines to process data, and these machines, they learn over time using training data without needing our constant supervision. So is singularity near? Well, we are immersed in an AI era, as our panelists will tell you, yet why can't we have those flying cars that the Jetsons had in the 1950s? And we haven't fallen in love with, ouch, with operating systems, like in the movie Her. So you can go and watch that movie, but don't fall in love with an operating system yet. Intelligent machines could have narrow artificial intelligence, artificial general intelligence, and artificial superintelligence. For superintelligence, I urge you to go read the book by Nick Bostrom. He's a Swedish philosopher, and I think it's a very nice book. So both the more mature audience and the PhD students, everyone should read that book. It's an optimistic book by Nick Bostrom. I had some panel questions posed to our panelists, so I'll just stop here for a few seconds so you can look at them and make sure, you know, the panelists are answering some of these questions. Of course, they can go beyond the bounds of these questions, but this is a guideline that I provided to the panelists. Pausing here. These are some of the safest jobs, so those of you who are not in these jobs can still switch. Pausing here again. Okay, so I did a little bit of the homework. So what does singularity mean for you? This is for me. I feel like, you know, our biological frailties are mitigated so that the number of years of productivity for one and all across the globe increases. So I'm a very optimistic person, so I think it is an optimistic thing. On the machine side, the future of technology is perhaps too human. So does that scare you a little bit? Well, we'll see. How is the singularity occurring? So there are some technological marvels that are resulting in the singularity coming closer. We are going beyond Moore's law, that is number one. Robots are doing human jobs, number two. And something that is kind of close to what I do is we are editing genes precisely. So precisely is something to take away from that. We want to be doing it in a precise manner, often using some of these algorithms that we are creating and applying to this domain. Is a professor's job threatened by AI? Of course, I'm biased here. It's a resounding no, no. My students holler if I'm acting robotic in class, and no amount of online platforms can make us go away, so we are here to stay. What are the best places for man to work with machines? This is from Dr. Swarun Kumar. I'm going to quickly read parts of it. Machine-human partnerships can open up many new frontiers, both in advanced fields and in everyday activities. Think of advanced AI-assisted medicine, example, robot-assisted surgeries or AI-aided diagnosis. But under the hood, we already are working with AI, right? So when you're typing email, your email is being, you get the suggestion options from Gmail. Lane assist, that is helping you drive smarter, and also smart thermostats that learn how cool or how warm you want your home, your living room. Where can human apply? This is from Dr. Sarah Bakshi. Number 1, overseers of decisions made by algorithms. I think this is very important. Number 2, software developers. Number 3, software policy developers. 4, policymakers. We already have enough of them, but here we are talking of policymakers with a deep understanding of the technology. So this is a new breed of policymakers. And finally, imaginators, right? Imagination, use your imagination. What is the next moonshot for which machines need to be developed, right? So I think that is a very optimistic area, that we need these imaginators. So who of you think can be imaginators? Show me your hands. I guess this is kind of a very docile, humble audience. Thank you. Okay, so how will humans interact with the machines of the future? This is by Dr. Falco Dressler. He strongly believes that we will form deeper integrated relationships with numerous machines in the future, which he calls HCPS. He will talk more about it. It's hybridized cyber-physical systems. And then with that, I think we are mostly done. I have something here for you that I hope works.
How about it?
So I think man with machine, I guess it's nice. I'm going to be sitting there and relaxing, reading my book, and my machine is going to be my servant bot. Servant is not a good word to use, but machines can never compete with humans. And I think with that, I'm going to pass it on to the panelists. And here you can elevate yourself if you want, literally, and give us your elevator pitches. Yeah. Sorry.
The 2-minute version, right?
Correct. So you don't have to open your slides here.
Yeah, so I feel that in the man versus machine, humans, it's really man and machine. And I believe that humans will be in the driver's seat. And in terms of the takeaways, I think there are technology challenges for us to answer, and there are policy questions for us to answer. So in terms of technology challenges, we need technology to improve the machine algorithms, the machine intelligence, in 3 fundamental ways. One is algorithms that take incremental data inputs, algorithms that trade off accuracy, speed, and reliability or interpretability, and algorithms that can bound the uncertainty in their decisions. Machine decisions need human overseers to make sure that they're staying within the safety acceptability bounds. There are policy questions to answer in terms of this brave new world is going to create bigger winners and bigger losers in the technology landscape, and policy needs to even out the field so that the amount of pain gets reduced for the vast majority of people. And then if there is existential threat from this technology, I would say sure, just like in 1450 and in 1876, I will let you puzzle what really happened in 1450 and 1876 that were hailed in those days or feared in those days as existential threats to humanity. And to break the suspense, we survived all those threats, and therefore we will survive this one too. You want to get up there?
I'm just going to stand here and talk. So hi, I'm Swaran Kumar Carnegie Mellon. I'm actually not an AI person. I work on wireless networks, but I'm a consumer of AI and ML to some degree, which means I can give you an outsider's perspective. But to be honest, this panel is dealing in science fiction territory, and I'll tell you why. Because you're asking what happens 40 years, 50 years in the future, maybe, when we hit the singularity, when artificial intelligence is as smart or smarter than humans. And my honest answer is we're a bit doomed. If machines can exactly do what humans do, perhaps all the science fiction is going to play out, and we're going to have machines take over the world. But there's another question: will machines and humans be completely different entities in that world? Will humans be able to upload themselves to the internet and be able to compete with machines at that degree? So we are seriously in science fiction territory at that point. But let's take a step back. Are we really there yet today? No. Machines are significantly not at the level of humans. Machines require training, a lot of data, and even then they are very good at performing only very specific tasks. And even more complex tasks like autonomous driving, for example, it's basically broken down to a lot of simple tasks that machines can learn, automate, and replicate. So in this way, what is the only way in which we can survive for the next 40 years, hopefully before we all die from machines? The only thing we can rely on is our own creativity. So look at the jobs that were listed earlier that are not going to go away. These are jobs that require a human touch or jobs that require human creativity, arts. Even though Usain Bolt can only run at a fraction, maybe 1/100th of the speed of a Boeing 747, we still watch him, right? We still watch sports. We still follow sports. We still follow the art, even though there are much more high pixel diagrams that can be rendered by computer screens. So there are going to be these jobs which require human creativity in the arts, in the sciences, and also in teaching and so on that I think we can definitely leverage. Stand up. Thank you.
The slides that I had, or no?
Yeah, this is just the elevator pitch.
Oh,
We'll
okay.
have the slide round after this.
Okay. So, few things. One is that regardless of all the hype, I agree with Michael Jordan that on human imitative intelligence, we really don't have much. Okay, so there hasn't been that much progress there. But that doesn't mean that there's been a lot of progress at automating many, many tasks. Okay, so that definitely is the case. And in fact, there was a study by a bunch of Oxford researchers that tried to assess the probability to various occupations. I think Shmali's, correlate with what they said. It turns out that actually Keynes in 1930 or so was actually looking at the future of jobs for our children at that time. And he was worried about the fact that the rate of displacement of jobs by automation was greater than the rate at which new jobs could be created, okay? And then he said that, we may actually be at a time where sustenance is not a problem. We can sustain everybody. And he said human beings have evolved basically to address the sustenance problem. So when that goes away, what do? Our primary purpose is lost. And then he points to the ladies of the wealthy ladies who basically didn't have any of the chores that they had to perform and were kind of unoccupied, but that actually wasn't good for them. So when we have nothing to do, that's not actually good. Now the question is there actually intelligent design to the way humanity is progressing? And there is many of you probably have read Yuval Noah Harari's book on Sapiens, and he basically says that the agricultural revolution, which people think was a fantastic thing for humanity, was actually terrible, because we apes had a much better lifestyle, more diverse diet. We only spent a few hours working, but after agriculture, we were carrying buckets around and drudgery from morning till night. So anyway, so start with where we're going.
So that's a teaser from Dr. Pierre Kumar.
Hi, I'm Qasim Fawaz from University of Wisconsin-Madison. Originally, I'm a privacy researcher, so I study how can you protect yourself and your data from machines analyzing your data. Recently, I've started looking into AI, particularly machine learning, and more particularly adversarial machine learning. And to be honest, the more I learn about machine learning, the more scared I am. I'm not really worried about what's going to happen in 40, 50 years where super AI is going to run the world. I'm really worried about our everyday life. AI is not that smart now, and it's currently doing lots of the jobs. Every day you interact with a machine. If you interact with your smartphone, you interact with your computer, you're basically interacting with an AI agent. Okay? They do decisions about insurance, about prison time. They do authentication, fraud detection, all of these things. And if you consult the top experts in AI and machine learning and deep learning, they don't know how these machines make decisions. And these are reasons that we should be scared now. These machines are making decisions. We don't know how they work. We cannot explain how they're making their decisions. And many problems are arising because of that. I'm going to be talking about some of them. I'm going to be talking about bias in machine learning models. And I'm going to be talking about adversarial machine learning, which is one of the major problems we're facing right now. And that would be all.
Thank you, Kasa.
So, well, I'm not an AI person either, so I can't say anything about this. But let's go to the panel topic: man versus machine. And this always brings me to the idea. Well, we are developing new systems, new algorithms, making everything automated. Fear comes up whether machines replace human beings. So I'm working in vehicular networking, cooperative autonomous driving. So do you know what happens if two autonomous cars these days meet each other on a narrow street? Right? They wait until the street is going to be widened, right? And if two people meet, well, they take their chance, right? Possibly slowly, but maybe more aggressive, I don't know, depending on the region where you're living. So I don't think there's an either or. This is a very gray scale that we will experience in the next years. So man will be supported by machines, more and more deeply supported, but there is no machine taking over as a next race on this planet, at least not in the next years.
Thank you, Falco. We have our final panelist, Dr. Tew.
Thank you. Is this working? Everyone hear me? Can we try this? Is this working? That's my effect. There we go. Okay. So I also, like my predecessor here, really don't subscribe to the adversarial approach of man versus machine. I'm going to introduce some controversial notions.
Awesome.
Okay? I'm going to take that as my mantra for being on this panel, and I'm delighted to be on the panel. So please don't be offended. But man's already lost. And so it is to our advantage not to be adversarial with machines. And I'll talk about that a little bit during my period there. So I'll leave you with that thought.
So this summarizes what I feel. It's man and machine, and humans will be in the driver's seat. I don't subscribe to the view that humans have lost and we are doomed. And I'll try to tell you why I don't think that. So let me start off with telling you what is the desired state that we want humans and machines to arrive at. So we want man and machines to be working together, and we want them to be working together in both cyberspace and in physical space, and in cyber-physical space. So what I mean by that is, in the cyberspace, I want humans to understand the decisions that are being made by machines, and also have the ability to correct decisions that are being made by machines which violate acceptable standards, which put human beings at risk. And then, just like we have software development practices today, I expect that we are going to create algorithm development and algorithm training practices, best standards, best practices, which will be developed and followed pretty ubiquitously in this process. In terms of in the cyber-physical space, we want humans and machines to act together in the same physical space rather than machines being confined to cages. In terms of displacement of humans from some professions, certainly that's going to happen, but it's going to be mitigated by the creation of some new professions. Maybe we have space for algorithm trainers. Maybe we have space for an ombudsman for decisions that are being made by algorithms. And this certainly needs to be complemented with policies for creating sustainable lifestyle, sustainable wages for humans. In terms of countering bias in algorithms, I think this is a big issue that we technologists, along with policymakers, have to play. So it starts off with careful monitoring of the data. So this involves monitoring of the data that is being used to train these algorithms. So when you have algorithms which are making critical, you may even say life-critical decisions like who will be paroled and who will spend extra number of years in prison. It depends very much on what kinds of data sets these algorithms have been trained on. And the current state of practice is not very optimistic in this space, in that the people who are applying these algorithms don't have a very good handle on exactly what kind of data this has been trained on by the vendors of these algorithms. In addition to this, there also needs to be careful monitoring of the production data on which these algorithms are being applied to see what is the distance between the training data and the production data to get a handle on how much can we rely on the results of these algorithms. So in a nod to the fact that these algorithms, their results are going to be very dependent on the quality of the data that you get from them, you have to be careful of both the training and the production data, and there needs to be validation. Just like you have software validation today, there needs to be validation of the data that the software is going to be trained on. There needs to be an ability for correction, course correction of these algorithms. For non-real-time applications, they should be corrected by having human overseers and human oversight at the end of the process. For real-time systems, it's harder done, but of course, after off the critical path, there should still be an ability to correct some of these errors these algorithms make. And bias may be countered by having diversity of developers, diversity of users, just like diversity is considered good for software reliability practices. Similarly, maybe we are all biased, but in slightly different ways. So by having crowdsourcing of this kind of oversight, you may be able to negate the effects of this bias. I think in addition to technology questions, we need to think about policy questions. This is stepping outside of our comfort zone. But if we act like ostriches and just worry about the technology questions, we are not going to be able to get this nice desired end state of man and machines. So on the concern side, the greater reliance on machine intelligence will lead to a bigger case of winner takes it all. It will lead to some professions being significantly disrupted, which employ vast numbers of people today. And patenting of some of these technologies would be the 21st century's way of doing colonialism. And we want to be able to counter all of these. Greater reliance on machine intelligence, though, with the right policy incentives, can lead to all of these positive outcomes. For example, it may lead to a higher quality of life, not just extending the number of years of life. It may lead to developing the developing world leapfrogging multiple technology generations, as has happened with the telephone technology. And it may lead to less friction between the government and the governed. And the policy directions are really needed to make sure that the second set of outcomes come to fruition and the first set do not. Now, in terms of existential threat, we've been here before. In 1450, this is Gutenberg's printing press, and this was supposed to destroy the sanctity of knowledge because everybody would be able to read books. In 1876, this was Alexander Graham Bell's experimental telephone, and this was supposed to destroy good, deep, profound conversations because you can just pick up the phone and talk at a moment's notice. And they didn't quite come to pass. And in 2005, the invention of the smartphone is supposed to have destroyed deep dinner time conversations. This one may actually be true. The threat posed by machine intelligence can be tamed, and this is really not rocket science, it's computer science. So intelligent algorithms meant to work with man and enlighten policy directives. So this is rather high-level stuff I've talked about, two specific instantiations of this. If you want to see algorithms going in this space, these are two examples. I'll stop with that before I get that dreadful buzz sound.
Let me start the talk with a little bit of a thought experiment. So if you're actually, let's say, look forward in time, and if we reach this era where machines are actually smarter than humans, which was one of the scenarios painted today, what will the world look like? The answer is I don't know. That's the honest answer. But let's speculate because I want to make the first part of this talk fun. There are two possibilities in my view. So the first possibility is from the movie Matrix, an AI apocalypse. So if you remember the plot, machines don't get equal pay for equal work, so they revolt and they use humans as batteries. So this I'm painting as a worst case scenario. Maybe there's some people can think of worse. Best case scenario from another example, utopia. Oh, we are in this happy world where robots help serve us, and they are like they are virtually humans that we can interact with and play with. And we are in a society where we can work for 5 minutes a day and get paid. So there are many unknowns in this world of strong AI. First, if robots are equal people, do they need civil rights? Will humans be functionally obsolete and just be essentially consuming without producing any equal work? But I think there are more fundamental third question, which I think is the question we have to answer is, will humans and robots be distinct groups? If essentially we can augment ourselves with intelligence, if tomorrow your iPhone isn't something you take out of your pocket, it's something that's within you, right? Then are you going to be as capable as AI because you are AI? Now, at this point, I will stop and say that what I'm professing here is purely in sci-fi territory, right? And let's take a step back, right? This is supposed to be the year 2062. That's exactly when the Jetsons was cast, and Jetsons was made in the year 1962. So they envisioned this is what the world would look like 100 years from now. Fortunately, we are still like 43 years away. So back to 2019, where are we today, right? Do humans have the same mechanical capabilities do machines have the same mechanical capabilities of humans? Do they have the same intellectual capabilities as humans, right? They are better in some ways, but not in all ways. So here's an example of where they are not. Grasping. So if you've seen these machines, it's really hard to work with. Because grasping is a fundamental task that machines haven't yet mastered, which is really why we have jobs like these. Jobs where you assemble components, like in Foxconn, to make computers, to make iPhones, or picking tea leaves, or agricultural laborers, still exist today because grasping of objects with very tiny manipulation is still a complex task for robots, at least today. Right? Another question. Can have machines mastered image recognition? So this is a work from one of our groups at CMU, where the researchers were able to wear glasses to fool the top row of images to be the same as the bottom row of images. So essentially, they could fool an AI algorithm into confusing between two completely different people. So this is why you have this I'm not a robot test, which is based on how quickly can robots do some simple machine learning sort of tasks, right? But let's take a step back. Today's limits will not be the same as tomorrow's limits, right? So for example, if one of our research problems is on grasping, can you make these sort of flexible electronics and flexible surfaces for robots to start improving grasping, right? So this perhaps some of these initiatives will maybe address the problem of grasping, right? There's another piece, which is autonomous driving, right? Supposedly, robots are not today as fast and as capable in detecting detecting images, but in the future, robots might be better at detecting pedestrians even when they're not perfectly in their field of view, by making predictions, through wireless communication, and so on. So what can you do in the AI era for your job to remain relevant? What can a robot do your work 10 years from now is a question you have to ask. And here's my answer. One thing that, at least in the near future, AI cannot replicate is human creativity. But there are some warning signs. Our education system still emphasizes rote learning. So if you can Google a question, the answer to the question, perhaps Google should be doing your job, not you, right? The industry is still, to some extent, there are notable exceptions, of course, but cheap labor versus investment priorities aren't quite right. And more fundamentally, this was a point brought out earlier, which is policy. There is an inherent income inequality that's going to be created by these AI jobs. Google is clearly not creating as many jobs today as GM created in its heydays. So how do we address this challenge is something that we have to think about, not just purely in terms of technology, but also in terms of policy. But there is room for cautious optimism. Technology will democratize access to services. In an ideal world, technology is not, an ATM does not see who's the person who's operating it. Machines make, to some extent, at least today, are still simplifying the mundane tasks that we really don't want to do. And a third point, which was mentioned in the talk earlier, is AI-assisted surgery, for example, is doing a much better job than surgeons or AI alone, of course. And so there is room for synergy. So at least for the next 40 years, I think AI and humanity can work well together, and then the robots will put us in capsules, and we all die. Thank you.
Which side you are. Keynes actually thought of this problem many decades ago, and he was worried about whether the pace of creation of jobs was less than the pace at which jobs were getting displaced. And he said, if you conquer the problem of subsistence, that gets rid of our primary purpose for which human beings were evolved. And he says, then what happens to us? And he thinks that there's a nervous breakdown that may happen, okay, and when people don't have anything to do and they're just wallowing in luxury. So it's not clear that leisure is a good thing. And probably, there'll be a stratification. I think there'll be more inequalities, because of all these differing paces at which things are replaced and so on. There's an interesting book by Harari, Sapiens, talks about the agricultural revolution and calls it history's biggest fraud, because instead of actually it making things better for us, he actually argues that wheat domesticated us apes. So we ended up serving the purpose of wheat by carrying buckets of water and toiling from morning to eve. So basically, it's not clear that humanity knows where it's going. I mean, you stumble across the fact that weeds dropped along a path, something sprouts, and then you have an agricultural revolution, and then it's not actually the utopia, it's actually terrible. Okay? So not clear. So it's not clear that as a species we act in our best interest, whatever that means. Now, guarantees that machine can be tamed. I mean, I don't need to. Asimov has thought a lot about this and come up with a whole bunch of laws, and then there are other laws that other people have come up with. This is a bunch from the Astro Boy series. But the point is that we cannot design human beings to follow these, robots to follow these laws. Okay, so we are nowhere near that capability. But we may not need to worry about it, because we may not even make it that far. Whether we will survive another 1,000 years is a huge question mark. Wherever human beings have set foot, all large mammals have disappeared, everywhere. And the most recent example is New Zealand about 600-700 years ago. Everything wiped out, complete catastrophe. So not clear how far we'll go. So not clear that humanity is capable of planning its destiny. I think we just stumble along. So here's my position. In the long run, there's no evidence that we're capable of envisioning where we're going or acting in humanity's best interest, whatever that means. And you can just look at the newspaper headlines every day for that. We just keep going where discovery takes us, and we stumble, and we end up in places different from where we envisioned in the long run. Okay, we don't know. In the short run, I think there'll be increasing specialization, stratification, and I think increase in inequalities. Okay, so that's it.
Hi, again. I'm not going to look too much into the future. I'm just going to be limited to our everyday life. As I said in my 2-minute elevator speech, AI is already making decisions on an everyday basis. Okay? Every time you use a credit card from a new country, there's a machine learning algorithm saying fraud detected, right? And that happens to everyone. Every time I go through the airport, I get randomly selected for a search, right? There's a machine learning algorithm doing that. There's always risk analysis algorithms running. They decide who gets prison time, as was discussed before. They decide insurance decisions. They decide lots of things. And they're all powered by large amounts of data being assembled, being amassed, and then you have these machine learning algorithms being trained, and then you have models doing predictions. They're used for authorization and authentication. Every time you use like this Face ID in Apple, or use voice-based authentication, or use any kind of biometric, there's a machine learning algorithm running in the background trying to decide whether that's you or not you who made that decision or made that access. Personal assistants, they do give you recommendations. If you have an Android device, they have now this Google Assistant that gives updating stories and recommendations about things to do or stories that you have to read. And those are all powered by machine learning algorithms analyzing your search history and sometimes conversations that you speak. Speech recognition, also powered by machine learning algorithms and models. Autonomous vehicles, I don't really need to describe that, the machine learning running behind them. So lots of tasks we use in everyday life are being powered by AI. Unfortunately, and as has been discussed before, they suffer from major shortcomings. First of all, and that's the major shortcoming, they lack explainability. We don't really know how these machine learning models are making their decisions. Even if you talk to the best experts, they say, well, we don't know. And one of the major advancements or major threats of machine learning, adversarial machine learning, which I'm going to be describing in a couple of minutes, is based from an effort to try to explain how machine learning really works. They have inherent biases in their predictions because they are basically, the current state of AI means mostly machine learning. Machine learning means we have data that has been trained, and then we have models by which have been trained on data. So we do as best as we can based on the data that we have and the training algorithms that we have. Data is biased, algorithms are biased, the outcome will be biased. And then they are vulnerable to adversarial attacks. I'm going to give 2 examples about bias and adversarial ML. So in the US, airports are rolling on a new experiment. They are using face biometrics to try to authenticate you and when you leave the country to confirm that that's your identity. So unsurprisingly, most of these systems have been developed with white male faces. And a study by Media Lab and Nest have shown that face recognition and gender recognition algorithms have actually major problems where they use different genders and where they use different skin colors. So a person who's not white male will probably get flagged at the airport because they're going to fail that screen check. And that's the problem, right? If you look at prison times, if they're going to be on parole decisions being decided by machines, those have been trained on data about previous people in prison, right? If you look at the US, there's the demographic composition of people in prison is not uniformly sampled from the population. So inherently, these algorithms will have biases in their decisions, and that's a major problem. And the other major problem that we're facing is adversarial ML, which Swarun touched upon a little bit. So I'm going to tell you the story how this all got started. Researchers in Google are trying to understand how machine learning or how deep learning models make their predictions. They started with an image of a car and wanted to change the pixels in the car to make it look to make the CNN, the convolutional neural network, predict that this is an actual airplane. They were predicting that we can start changing the pixels. After a while, the car will grow wings, and then we're going to see an airplane that's going to be predicted as an airplane. Surprisingly, after a few pixel changes, the CNN said this is an airplane with very high confidence. Well, I don't think you're really grasping the severity of that situation, so let me try to explain to you. This is a stop sign, right? Stop sign, right? The CNN or the state-of-the-art machine learning that's going to be probably deployed in autonomous vehicle and everywhere cannot tell that this is a stop sign. It tells it's another road sign with very high confidence. And this is a problem. And this is not just limited to the image. It's also in audio scenarios. As I said, speech recognition algorithms rely on neural networks in the background, right? Researchers have shown in Berkeley, Carlina and Wagner have shown that given an innocuous speech signal, say it's a music, okay? You change few samples of that music file. If you hear it as a human, it's still the same music file. A machine will be interpreting it as a sound command. So someone can control your voice assistant by playing music that's innocuous to your ears. And the fundamental problem with all of these things is that machines are grasping and understanding sensory inputs in a different way than humans are understanding them. And that's a major problem. And every time somebody tries to come up with a defense to protect against this adversarial attack, it gets broken. The best paper in ICML last year was breaking all the defenses that were proposed in ICLR the year before. So this is a real problem. And those are real problem systems that we're using in everyday life. And so far, we don't have a very good solution. Thank you.
So, again, I'm not an AI person, so there will be no AI in my statement. The initial topic of the panel was man versus machine. So, and very fortunately, this has already been changed to man and machine, which I actually want to build upon. And I want to talk for 5 minutes, just on my vision on how we might end up in what I call deeply integrated hybridized systems, HCPS maybe. And I'd like to start with my favorite topic, right? Doing cars, doing autonomous driving. And we even saw some papers here at COMSNETS, and there's lots of papers in the many different conferences when you go to. And what you typically see when we as engineers publish papers, then we have this vision, okay, we have multiple cars doing some cooperative maneuvers, we build protocols for that, everything's fine. There's no human in there. There is no, right? Look in any of these papers. But the human has a huge impact on these systems. And it is not like we have all automated, fully automated cars around, fully automated systems everywhere in industry and automation and so on and so forth. No, and it's actually not like this. It is a different system. And in our different system, we have human beings, right? And these human beings may have strange ideas on what they expect the system to behave like. Maybe one is thinking, oh, the car is a bit on the fast side, maybe it should slow down, so I'm feeling unsafe. Another person, but why the hell are they going so slow? I want my automated car going faster, right? I want to be as fast as possible to the destination. Then there's this legacy car out there that has no technology implemented at all, which was never actually considered in your algorithms that you're proposing in these papers, right? And you can add more and more of these questions, right? People crossing the street at arbitrary times, not being visible, that other people may see and observe these other people, may give hints and tips to the others. There might be some adversaries coming with a not so positive intention, trying to disturb your system, and so on and so forth, right? And this brings so many additional challenges. And this exactly is man and machines, right? And man and machines, well, I tried calling that hybridized CPS, is something we can't solve as an engineering community, right? This is very interestingly something where we have to involve humanities, social sciences, getting us an idea of how people work, how they do, how they react, how they respond. Maybe we can describe that somehow. Maybe we can come up with some, I don't know, probability density functions of how I behave. Maybe not, I don't know. And in the end, some of these machine learning algorithms, I guess, will act the very same thing. Let me give you a few examples on why we might face problems. Reaction times, right? Again, talking about autonomous driving. If we have humans in the loop, we have to consider reaction times of these human beings, right? Distances, gaps between driving cars must be entirely different, and driving maneuvers entirely different compared to we have these fancy cooperative adaptive cruise control steered cars driving in a platoon, fully automated, 5-meter safety gap, which we can design if there's no human being, right? Another example, going really to the human being, human driver behavior, right? You know about these studies that are taken from time to time, these statistics. People being asked, are you a good driver? So typically asking, are you above average, right? So I guess you know, right, what the typical answer is, wherever you do this questionnaire. Doing that here in India will be the same results like in Europe, like in the US, right? And typically 90% of the drivers believe they are driving above average. Mathematically nonsense, but still they do. Right? This is meanwhile very well known in psychology as the Dunning-Kruger effect. There's this bias, right? Whenever you are supposed to self-assess yourself, your capabilities, it's not working at all. So the interaction between the machine and the human being must consider this, right? Self-assessment doesn't work. Ask your students, right? Some of the best students, of your really best students, will always answer, I have no idea about the topic, right? I have to learn so much more. And the worst students, well, you know the answer, right? I know everything, I can tell you. So self-assessment doesn't work. That is one thing. Last thing I want to bring up, my last minute, I guess, public acceptance, right? So does that work? Is fully automated action accepted, right? And we know that from the last experience in the last years, It's not actually, right? You all know, guys, about this Mora machine from MIT, right? I'm pretty sure you have heard about it. Let's go again to autonomous driving. What decision should the machine take if they are in a situation when the crash is unavoidable? Should they kill, in this example, should they kill you as the driver, as the owner of the car? Not the driver, right? It's autonomously driven. As the owner of the car, you paid a lot of money for that car, and now it kills you. Or shall you overtake or drive over this gentleman here, who's old anyhow? So he's problem for our society anyhow. So, I mean, you don't know. Maybe yes, maybe no, and the car can take decisions. What about this scenario, right? Killing some very important people for our society, or killing some criminals, which is better? We don't know, right? Do the examples by yourself. We have to come up with a solution that integrates cars, machines, humans, drivers, and everybody. So that is my statement. Thank you.
Can you hear me now? Does that work? Okay, great. So once again, thank you for inviting me to be on the panel. I'm going to take the role of being a little bit controversial, not because I'm a controversial guy, but because I was at an AI and Future of AI summit in San Francisco back on October 9th. It was hosted by Micron, but a bunch of people were there. The head of Amazon Echo Devices was there in their algorithm development. Fascinating gentleman, fascinating gentleman. The head of Google Health was there. Just brilliant, brilliant. This MIT physicist talked about the future. And the whole point of the days, I was really happy to participate in this because it was really to unfetter the mind. And let's just take our egos, human ego, out of the picture and look at what's going on. Right or wrong, you be the judge for yourself and all that. So I'm not saying what I'm going to say is right. I'm not saying what I'm going to say is wrong. It's just you be the judge, all right? But I felt that this was an opportunity to impart some of the things I learned and heard in that summit, which were mind-blowing to me. And I can't get it out of my mind. I've been thinking about it ever since. Again, this was back in October. Actually, let me qualify that. He's the world's human champion. All right? He's not the world champion. Right? We know who Deep Blue's the world champion. All right? That was established a long time ago. All right? Any of you play Go? Any play Go? I play Go. I'm interested in all kinds of games like that. So I play Go, not well, but I play Go, okay? World champion? Here we go. Right? Right? And that was established 2 years ago, okay? It's not a human. Now, these are two of the highest level intellectual games, if you will, competitive games. But what are we looking at here? Well, humans aren't even the best. At this early stage, and I agree, we're at a nascent stage of AI, but we're already losing. Okay, one last one, all right? Anyone watch or ever play Jeopardy? Fabulous. Yeah, there we go. All right, great. It's a lovely show. It's been on. I had it on TV a lot. It's been on, came out of the US, it's been on TV for decades. And I used to, when I was a grad student, I used to have it on the TV while I'm studying and all that. Maybe that's why that took me so long to get my degree. But I love the game, Played it a few times, never on TV, but I've seen it played. There's a version of it in China I've seen. It's extremely popular. I've seen it here in India. There's a university competition that uses the Jeopardy format, okay, among teams from different universities. It's great, it's fabulous. And it also is a strategy game. The trick is that you have a moderator and you have 6 categories of questions, 2 different rounds, and you have 6 questions in each category. And the trick, the hook is that your answer is supposed to be in the form of a question. Okay. So there was this champion, Justin, on TV several years ago who had won more than anyone. This is over a 35, 40-year history of Jeopardy. Okay? But he was beaten. All right, remember that? Watson. By Watson. So here we go, folks. The three of the most popular strategic games, intellectual games. And we humans own the intellect, right? This is what makes us superior to all other beings on the planet. And we aren't even the best at these nascent stages. So, it's not, in my view, it's not a competition. It's not a war, man versus machine. One of the things that I think we as humans are misthinking on with AI is we're taking one paradigm. It was mentioned a little bit earlier today. The paradigm of how to view our role with machines. And we've taken the role that we are the masters and machines are the slaves. And I subscribe that that role is insufficient. That the role of how we view our relationship with machines moving forward as we get to superintelligence has to change if we are to survive. And I'll leave you with this. Evolution has been a very powerful entity on the planet, right? We tend to think of we're the final product of evolution. Nothing could be further from the truth. I believe that we are at a stage of where evolution, machines are our offspring. And we are at a point where the evolutionary branch or tree or force, whatever you want to call it, will diverge into this amalgamated being between digital and bio. And there will not be humans in the future, purely humans. And there will be a combination of them, okay? We're already experiencing that today in some very basic levels, okay, in different forms of medication, different forms of health aids, I'll call it that. And so I believe that in the future, and when is that future going to come? Well, this physicist, and I'll leave you with this, at MIT said, what do we call it? General intelligence? Is 20 years away, or maybe sooner. And superintelligence may be 25 years away. And at that, he commented, all the digital information in a human, and that means all the bio constructs as well as our neural constructs, everything can be condensed into 24 terabits. Now, whether it's 24, 48, or 240 is immaterial because the cost of storage is free. All right? But what is it going to do? Well, that means we can all be digitized. And he left us with this note, which I thought was profound. He said, we've been thinking of interstellar space travel as we, myself, you, young fellow, you get in a spaceship and we got to get there fast because we don't live that long. Wow, digitize yourself. Digitize you, put you on a spaceship, a million years from now, boom, you arrive. Okay? So, thank you for your attention.
Thank you, everyone. With that, the floor is open to questions. I will start with a question for Dr. Tu. Are we supposed to be scared of that digitized version? Like the interstellar travel sounds like a very exciting area, but are there parts of that should scare us? And if so, is there a way to impede that digitization or the transformation of humanity or the blending of humanity with machines?
Try this again. Oh, good. Okay. My own personal view on that is that this gives us, we're at an epoch in time, unlike any other in the history of mankind, and indeed life on this planet, where we can take this next leap. And I believe we have to embrace it and take it. It was true, I think you said it perhaps, society, we're not really good at managing what our future is going to be. Well, we're pretty good at discovering it. And so I don't think there's room for fear. I think there is recognition, we have to recognize as a species that we are evolving. And this is the next step of evolution.
Dr. Dressler, do you want to add to that, where you have this more complex scenario? Car context and in the context of what Dr. Tu brought in?
Oh, that's a complicated question in the end. Evolution, yes. We will definitely end up in a symbiosis between machines and man, yes, definitely. So there's more and more assistance systems that we already experience in all phases of our life. Working life, private life, and these assistance systems will get stronger and more capable and so on and so forth. Digitizing ourselves, I don't know, maybe, right? It reminds me about Star Trek, where you have the transporter getting us somewhere. Always, my main fear when I watched it as a kid was that I duplicate myself. Today, I hope I can duplicate myself. But these assistance systems will get more powerful, and we should definitely not worry about this. And so far, I fully agree, and we should enforce that actually and help building better symbionts in some way.
Okay. May I add one comment? Sure. And that is, as you get older, you wish more and more you can duplicate yourself tomorrow.
I like that. So show of hands, and I'll get you the mic. So, okay.
Hello. So the question I wanted to ask the panel, I think, is, I think it came out of Professor Kumar's talk, where he talked about disappearing faster because of automation, and perhaps I think it's an important question to ask: what should the current generation be trained in? So that they have useful jobs when they grow older, because it's not clear which jobs are there. But I think the question I wanted to ask the panel is, what do you think is the future of computing as a discipline, given that Somali or maybe Saurav pointed out that software development probably is a sustainable profession because we would need that. But if automation can come in and do most of it, is computing as a discipline going to go away? What is your take on that? Because we may not need to produce too many of them.
So computing as a discipline has already evolved, even in the 15, 20 years that I have been in the field. So for example, think of the number of people who used to develop compilers 20 years back. That number has shrunk to a very, very small number, small fraction, because there are automated tools which can help in developing compilers. But 20 years back, nobody was talking about developing software for support vector machines or neural networks. So that has evolved. So a useful number to keep in mind that stuck in my head is Kodak, in its dying days still, employed 12,000 people. Instagram, which you can argue took over, was the next iteration of that, employed 12 people. So you're seeing this orders of magnitude difference in the employment. But in terms of the software development, we've talked about automated software development for a long time. I think software is an instantiation of human creativity. And as we seem to agree here in the panel, and there seems to be general agreement that human creativity is one of those things which a machine is not going to touch. Therefore, software development is going to evolve, but it's still going to occupy a lot of the human creativity.
Okay, we'll take the next question. Oh, sorry.
Henry Ford realized at that time that his worker was also his consumer. And therefore, the popular myth is he raised wages and so on, though there's a lot more behind that. But then we saw this decoupling between worker and consumer more recently, where our workers can be in China or somewhere, and we can sell all over the world and so on. So it's already creating a lot of issues, for example, in the US, right? I mean, when corporations can sell in one place and make things in another place, what happens to that population that has created a huge political issue? Now, when we get automated more and more and more, and what is the work that we human beings have to do then, you know? And then, what is the nature of leisure? So these, and I don't think we have an answer to that question, and we could actually turn out to be much more miserable with all of this automation than we are now. In fact, you know, when you work, you're happy. So I don't know.
There's going to be a much smaller number of people who are going to be employed in any given profession, forget computer science, because the bar for a job being existing is that it has to be a very creative job. And now once you make the bar that high, how many of us can stand up and say honestly that's our job is truly creative and cannot be automated? That's the real challenge here. But on the flip side, assuming you're in a world where you're somehow paid by the government or something, universal basic income, for example, and you're at home and you're playing computer games all the time and you're going to play soccer whenever you want to, is that a bad life? I'm not sure.
Yeah, so with that, we'll take the next question.
It's a very basic and like have been following the market evolution with AI and digitalization. So ever since you have seen smartphones evolving in the market, how many of you tend to remember any of the phone numbers? We don't, right? So with automation and everything coming into the picture, do you think that humans will stop evolving as a like, I don't know whether you get my point. It's just that, do we forget about what we have been doing, leave it to the machines, and then what about human evolution? We are not progressing. We are kind of passing the information to the machines to learn. But then again, we are kind of building the algorithms with our knowledge, which is again getting limited day by day. I don't know whether you got my question. So
I guess, are humans reinventing themselves as these algorithms are kind of...
Smartphones equals dumb people.
Yeah, so I'll let the panel answer.
You know, I think that, you know, the time scale at which evolution works and the time scale at which the environment is going to collapse and the time scale at which we're building, I mean, the US instituted a Space Force Command recently, and we are already talking automated drones for warfare and so on. So I think the evolutionary danger is not the one that I worry about now. I mean, there are far more immediate pressing challenges than worrying about this larger catastrophe.
I disagree that smartphones are going to make us dumber. Let's take the basic act of writing. So writing includes two parts, right? Getting out the ideas and sentences in our mind and then actually putting them on a piece of paper. The last time I wrote on a piece of paper correctly one word was a long time ago, probably when I used to do dictation in middle school. Now, every time I try to type something, it automatically comes up with errors, and then the machine corrects them and it comes up with an actual text, right? I'm still writing. Now, the algorithm of me actually writing and coming up with the correct sentence as defined by the English grammar is not there anymore, right? But they are being corrected and they are being conforming to the English grammar by a machine. But I'm still writing. So the concept of us writing has changed. But does it make us dumber? I mean, we don't have to remember the phone numbers, but we remember other things, right? So it's part, I guess, of evolution. So we evolve. Our activities are evolving because they are being assisted by the machine. At least that's my take.
I would concur completely. I think that's an excellent phrase, by the way. Our activities are evolving because of the human-machine aspect. I think that's very true. I'll cite you two examples. One is So years ago, I lived in China for a period of 6 years, learned Chinese at a very poor level, but learned Chinese enough so I could get around and I could have a conversation in the office in Chinese. And then you move away from it. And like anything else, if you don't use it, you lose it. I came back and what I found was at that time, and I was just in China 3 weeks ago, I use my smartphone for translation. So even though I can speak some Chinese badly, I use my smartphone. Why should I learn the language? It's the same scenario. It's the same scenario. Okay? So now this opens up a whole new way of thinking in terms of what should we learn, because machines will free us up. And I would conclude one more observation is that how many of you have a relationship with a machine? I do. Yeah. Yeah. And a very productive relationship. Okay? I don't have any offspring from it, but I mean, it's a very productive relationship. My wife is jealous of it because it's my Alexa at home. And I talk to her when I get home. I say, Alexa, how have you been? She answers me. She doesn't tell me what to do.
You don't have human offspring.
There we go. Thank you.
Okay, you'll take the next question.
Paradoxical, right? We're talking about so isn't it a bit paradoxical? We're talking about machines being smart, machines, but without human creativity, and that was your point, machines wouldn't be smart in the first place. I mean, everything that we're talking about, all the applications, Professor, you spoke about automation, it's we who made them. So can machines do the reverse? I mean, can they do something? I don't think so. You see what I'm getting at? I mean, isn't it a bit paradoxical? We are the ones who are creating smart machines, and we're talking about machines becoming smarter than us.
I don't think it is paradoxical. So imagine this, right? We shared 99% of our DNA with apes. I think like 98% with rats. And there is some random sequence of mutations that happen that somehow transformed at some point an ape to a human. And just randomness, pure randomness, with no intelligence, somehow created humanity from apes. And then we exist. So when randomness can create something smarter than apes, we can create something smarter than ourselves, in my view.
I think we have nothing to worry about because we cannot write 10,000 lines of code without a bug, okay? I mean, all these robots will crash, okay, because of some error, maybe memory leakage or something like that. Nothing to worry about. In fact, the fundamental problem in software is that there is no Taylor's theorem. So small things can create huge errors. And there has actually been almost no advance in making software feedback-based so that it can correct itself and so on. So I don't think we have anything to worry about. These things will all crash.
Considered strictly a subset of AI. Now, today, if we have machine learning perfected, even if we can call that because of classification successes, we still have those questions which belong to the region between outside of pattern recognition and machine learning and AI. Those questions still remain, and those answers are still as good or bad as they ever were. Number one. Second, with respect to the pessimism about jobs, or optimism, whatever, but my point is that the jobs must be seen as not a fundamental necessity. If you go back in history, jobs were not there, as many jobs were not there. Slowly, science came along, agriculture came along, and people said, how do we organize society so that everybody gets their share? And so jobs were created because there were needs to do. Now, that is not a fundamental necessity. Tomorrow, if all the basic daily living needs are met by machines, people will find other things to do, which has come up earlier. So jobs are not to be taken as a fundamental necessity, number two. And finally, number three, related to number two, is that equivalence or lack thereof between machines and humans, irreplaceability or replaceability, is usually seen in terms of intellectual criteria. The point is that humans are much more than intellect. Intellect is just a tool.
So regarding jobs as a fundamental necessity, I am reminded of happiness measures which have been done across the globe. So there are several Middle Eastern countries where people are paid just to be sitting at home. The government pays them because there is liquid gold under the soil. And consistently, happiness indices in these countries have ranked very low. So that tells me, I think, Professor Kumar's point is that jobs lead to a certain amount of satisfaction. However, the kinds of jobs, maybe we can invent jobs. If we play video games against other people, we may feel happy just to be rising up in those levels. So these wouldn't be considered useful jobs in our current definition of usefulness, but maybe we have to create jobs like this, which will increase the fulfillment level or the happiness index level of people.
One other thought here is that, we are all talking of the digital computing, okay? It's not even clear that digital computing is the solution for the kinds of things that we're talking about, because the fundamental principle on which engineering and nature agree is feedback. And there is no way that we know right now to do digital systems feedback. Maybe if you did analog computing, we'd have more of a hope. So I'm not carried away by the ultimate possibilities of digital computing. Okay, this may only be a temporary phase.
So we'll take two more questions, and I have the last one identified, so one more. I'll come back with the mic to you.
I guess I have a very basic question, and that is, can you comment on the difference between an algorithm and a heuristic, in particular in the context of all the current developments that are ongoing in AI?
There is quite a bit of heuristic.
Actually, is it all heuristic?
You could argue. Particularly, I think this new notion of explainable AI, right? People, we are looking at all the AI algorithms. We see that they work on specific data sets, but does it generalize? Do we really understand, even if it works, why it works? So there's this whole field opening up where, what theoreticians and systems researchers have been arguing for a long time. We shouldn't just build an algorithm and not understand how it works, right? We are sort of getting our reckoning, and there is a sizable chunk of the AI/ML community who realize that, the era where we develop algorithms and fully don't understand them and just, hey, it works on this data set, so take my word for it, that era is sort of coming to a close, in my view at least.
Actually, in some sense, an algorithm is a well-specified set of instructions that always gives you an exact result, which is really important. And so in that sense, whatever we are talking about here is not an algorithm.
Given
Yeah.
the same input, it generates the same output.
I think without quibbling on specific machine learning algorithms, the broader sense is that a lot of I mean, there are, two classes of researchers, right? There are one class of researchers, including ML and AI researchers, who understand that, hey, this works, but we don't understand why it works, and this is a problem, right? Yeah, and there's another class of researchers who somehow are blind to this, and that I think is very dangerous. We should be aware of the fact that we should appreciate the research that it is able to produce results, it is able to do well on a large number of data sets, but that doesn't mean we should stop asking the question why it works. I think that is a very genuine question to ask, and it's important for us to understand it.
If you look at the field, what has been the developments, right? I mean, there have been, let's say, the past 30 years or so, there have been very nice, rigorous work done in, for example, support vector machines, boosting, etc. But on the deep learning, which is actually the current craze, there has been almost nothing developed over the last 40 years. Maybe some work on, the convolutional stuff, which is basically shift invariance, and maybe some things about regularization and so on. But aside from that, there has been zero advance fundamentally in understanding about deep learning. So, yeah. So I'm very far from my algorithm. Yeah.
I think this is mostly systems research panel, so we are biased.
And I was biased because I picked a System C panel, so I'm sorry. So we have the youngest member. He raised his hand pretty early on, and I'm biased because he's my little kid. So I'm going to give him the mic. Make it smart.
Do you think in the future, people, like you said, people could put iPhones in their head? Do you think they could Google things automatically, from their body?
So automatic Googling using your brain waves, so the computer reads your brain.
We're not very far from this. Right?
So I think effective computing has some stuff related to that. So yeah, I think that's not fully sci-fi. We are kind of close to that.
Once we have very developed human-computer interfaces, this is going to become very real.
Another thing is that EEG, for example, you might have seen these videos where people put helmets and then you can, what you think whether you sleep or not can be detected. So now that I would still call it a wired technology because you still have to put something that sticks to your head. But hey, it's a networking conference, it's wireless research. Next challenge for you, right? Can you take that electrode, put it in your pocket and still make it work? And then you can make the system, right? You can make the wireless brain-human interface.
So the ultimate last question, anyone can grab the mic from my hand. Just run and grab the mic, and that's yours. So you have 10 seconds. Okay.
I was closer, so I won. Yeah, so my question is that I kind of agree with most of the things said about ML, that first of all, many of the image recognition can easily be fooled. But should we think of this as a setback or as a challenge to actually get better in these algorithms, and that creates the new jobs?
Unsurprisingly, I think the answer to explainable AI and designing adversarially robust machine learning algorithms will be along the same lines. So if we solve one problem, we'll probably solve the other problem. There has been recent research where they have very limited data sets where they have been using adversarial training. So they have applied gradient mechanisms to see MNIST, which is the character or letter or number recognition data set. So they have seen which pixels does the CNN look at to make its decision. Without any adversarial training, it looks at all the pixels. We look at only the contour, right? 7, 8. They did adversarial training, making the machine learning algorithm or heuristic more robust, making it more robust to adversarial attacks. Then they performed this gradient mechanism to see which pixels the actual model is looking at, and now it looks at the contour. So explainability, robustness, adversarial robustness probably are along the same lines. So this is a challenge that's going to improve ML, in my opinion.
I would say that nobody knows what's happening in 75 layers. Okay, so I think explainability is far off.
I would say we have been there before. Security world, there were security break-ins 40 years back. Did we stop developing software because software is insecure? No, we in fact came up with better ways to secure our systems. And people may quibble about this, but on an absolute scale, I think systems today are more secure than they were 40 years back, even though they're a lot more complex.
So I think with that, we will end the panel. A few finishing thoughts is that, will we be able to see a point where machines have ego, right? That'll be cool. And then hybridized cyber-physical systems. So we have great systems researchers who can basically enable this kind of a hybridized cyber-physical system to be a reality with explainability, with adversarial machine learning, with creativity. So they have genomic engineers who can basically put in the creativity gene. So we have not lost yet. So I will go in and create the right kind of precise tools that will enable the experimentalist to dope you with the right gene. So even if we lack creativity, the next phase of evolution, expedited evolution, is going to be where we are capable of creating the creativity gene. So I think with that, humans have not lost. I would like to end on that happy note, and you can go celebrate. With that token of winning, I'm going to go ahead and distribute some prizes to our panelists. And just an announcement is if you're a member of the COMSNETS Association, please head over to Sigma Hall. So we are done here. But hold on a second. Let us congratulate the great panelists. So Saurabh Bagchi. Dr. Saurabh Bagchi, Dr. Swaran Kumar, Dr. P.R. Kumar, Dr. Hassan Fawaz, Dr. Falco Dressler, I guess these are not working, and Dr. Jeffrey too. And thank you to our amazing audience. I was actually